Imagine one ordinary potato entering a factory, and minutes later emerging as a perfectly golden, incredibly crispy chip. Here's what nobody tells you. Creating that crunch requires farming science, precision cutting, hot oil, and perfect timing. A fresh potato carries mostly water, so the factory must remove that moisture while protecting its delicate structure. And the journey starts long before frying, because farmers must grow potatoes with the right qualities for processing. So what makes one potato perfect for chips while another potato completely fails inside the factory? The answer begins underground, where soil, weather, variety, moisture, and starch quietly determine tomorrow's crunch. Chip processors generally prefer potatoes with high dry matter because that helps create a crisp texture during frying. Too much reducing sugar can make chips darken quickly, creating unwanted color and bitter flavors. That's why factories test incoming potatoes before thousands of kilograms ever reach the production line. Now harvest begins, as powerful machines lift potatoes from beneath the soil and separate them from the earth. Inside the harvester, vibrating screens shake away soil, stones, leaves, and other unwanted field debris. But bruises matter, because damaged potatoes can develop discoloration that becomes obvious after processing. After harvest, loaded trucks carry enormous quantities of potatoes from farms toward specialized processing plants. At the factory, giant receiving hoppers swallow the harvest continuously, transforming farm produce into an industrial stream. And this is where the real mystery begins. How does a rough farm potato become a perfectly uniform chip? First, powerful washing systems blast away soil, stones, leaves, and everything else carried from the farm. Inside these washers, rotating paddles tumble potatoes gently enough to clean them without creating unnecessary damage. The cleaned potatoes then pass through inspection systems where damaged, green, rotten, or undersized pieces can be removed. Some factories use optical cameras that rapidly detect color differences invisible during the hectic production flow. Once approved, potatoes move toward peeling, where machines remove the skin at remarkable industrial speed. Abrasive peelers rotate potatoes against rough surfaces, scraping away thin layers of skin within seconds. The goal sounds simple, but excessive peeling wastes edible potato, while insufficient peeling leaves unwanted skin behind. That's why peeling machines constantly balance speed, pressure, water flow, and contact time. After peeling, another rinse removes loose skin fragments before the potatoes enter the most precise machine yet. Imagine feeding thousands of irregular potatoes into one machine and receiving nearly identical slices seconds later. Precision slicing begins with rotating blades engineered to cut potatoes at extremely consistent thicknesses. For classic potato chips, slices are often only around 1 to 2 millimeters thick. That tiny measurement matters because thickness controls cooking time, moisture loss, texture, and final crispness. If slices become too thick, they may stay soft, too thin, and they can burn or break. Crinkle-cut products need specialized blades that create ridges while slicing every potato at controlled thickness. The freshly cut slices now carry surface starch, so they enter another washing stage before cooking. Water sprays remove loose starch that could cause slices to stick together or affect their final appearance. Some production lines also blanch slices, using controlled hot water to influence color and reduce unwanted sugars. Blanching conditions vary by product, but careful temperature control helps processors achieve predictable frying color. Next, the slices must lose surface water, because water meeting hot oil creates violent bubbling. Vibrating conveyors shake away droplets while powerful air knives sweep moisture from every moving slice. The slices are now clean, uniform, drained, and ready for the transformation that creates their famous crunch. But the instant those pale slices hit hot oil, everything changes, and the next few minutes decide their destiny. The moment each slice touches hot oil, its surface begins changing almost instantly as trapped water turns into steam. Explosive bubbles aren't boiling oil. They're moisture escaping from inside the potato under intense heat. Commercial fryers commonly operate around 160 to 190 degrees Celsius, depending on the product and equipment. That's roughly 320 to 374 degrees Fahrenheit, hot enough to drive moisture outward extremely quickly. As water escapes, the potato loses weight, shrinks slightly, and develops the porous structure behind its crisp texture. The factory carefully controls residence time because every extra second changes moisture, color, texture, and flavor. A chip that leaves too early can remain soft, while one staying too long can become dark and bitter. That's why conveyor speed and fryer temperature work together like two sides of the same equation. Meanwhile, oil continuously circulates through pumps and filtration systems to maintain stable cooking conditions. Tiny food particles can accumulate in oil, so filtration systems constantly remove debris from the cooking environment. And now something fascinating happens. Browning reactions begin creating the flavors we instantly recognize as fried potato. Heat drives reactions between sugars and amino compounds, building complex aromas, roasted notes, and golden color. But engineers must control browning carefully, because beautiful golden color can quickly cross into unwanted darkness. This is where optical cameras become critical, scanning moving chips faster than human eyes ever could. Cameras measure color patterns and identify chips that fall outside carefully programmed quality ranges. When a defect appears, precision air jets can blast that individual chip away before it reaches seasoning. Meanwhile, perfectly cooked chips rise from the fryer on perforated conveyors, draining excess oil as they travel. Fresh chips are fragile, so conveyors move them gently to prevent cracks, fragments, and unnecessary product loss. Next comes cooling, bringing the chips down toward a temperature suitable for seasoning and packaging. Powerful fans circulate filtered air across the chips while keeping the production environment clean and controlled. And now the chips are finally ready for flavor, but seasoning must land evenly across every piece. Rotating drums and vibrating conveyors tumble chips gently while fine seasoning spreads across their warm surfaces. Salt particles stick naturally to tiny surface oils, creating that familiar flavor with every bite. Different flavors require different seasoning blends, from simple salt to cheese, barbecue, chili, or smoky spices. But the factory must control seasoning quantity carefully, because too little tastes bland and too much overwhelms the chip. Sensors and calibrated feeders regulate powder flow while production keeps moving at incredible speed. Now the transformation is almost complete, but the factory still has one major challenge: protecting the crunch. The chips are finished, but their biggest enemy now is moisture, because even a little can destroy that crunch. That's why packaging starts immediately, with machines carefully measuring portions before dropping chips into forming bags. Multi-head weighers divide chips into precise portions, balancing speed with accuracy thousands of times every production shift. The packaging film moves continuously, folding around each portion before heat seals create an airtight-looking package. That familiar puffed bag isn't simply empty space. It helps cushion fragile chips during transportation and handling. But the machine must seal each bag strongly enough to protect freshness without damaging the delicate chips inside. Immediately afterward, automated systems inspect the package weight, seal, shape, label, and overall appearance. A precision checkweigher can detect packages that fall outside the manufacturer's permitted weight range. If something fails inspection, automated mechanisms quickly divert that package away from approved production. Cameras also examine seals, searching for wrinkles, incomplete closures, damaged edges, or packaging defects. Even the printed information receives attention, because traceability connects every package to a production batch. That tiny code can help manufacturers trace when and where a product was produced. Quality teams also sample finished chips, checking color, texture, seasoning, moisture, and flavor before release. One sample may be measured mechanically, while another gets the simplest test of all, a human bite. One sample may be measured mechanically, while another gets the simplest test of all, a human bite. That's where human experience still matters, because machines measure numbers while people recognize subtle sensory differences. Once approved, bags move into cardboard cases, where robotic arms arrange them into precise shipping patterns. Robotic palletizers stack those cases layer by layer, creating stable towers ready for warehouse transport. Automated guided vehicles can then move finished pallets through enormous warehouses without constant human driving. Warehouse scanners record locations, batches, and destinations, keeping thousands of cases organized for distribution. Then forklifts and loading systems transfer those pallets toward trucks waiting outside the factory. From there, the chips begin another journey, traveling through distribution networks toward supermarkets, restaurants, and local stores. And after all those machines, measurements, inspections, and kilometers, the product finally reaches a store shelf. Think about it. What looks like a simple snack has passed through dozens of carefully controlled decisions. Every slice began with agriculture, every crunch required heat, and every package depended on precision. But the story isn't finished yet, because this global industry is changing faster than most people realize. But the story isn't finished yet, because this global industry is changing faster than most people realize. New technology is reducing waste, improving consistency, and helping factories use energy and water more efficiently. Artificial intelligence can analyze production data and detect patterns that humans might miss during thousands of operating cycles. Imagine a factory predicting a quality problem before the first dark chip even appears. That's the future of manufacturing. Machines don't simply react anymore. Increasingly, they predict, adapt, and optimize. Yet beneath all this technology, the journey remains beautifully simple. Earth, potato, heat, seasoning, package, and finally you. The next time you open a bag, listen closely to that first crunch. You'll hear an entire factory inside it. From one humble potato to a global snack, every crispy bite carries a surprisingly sophisticated manufacturing story. The journey began with a potato beneath the soil, but now that same potato has become a finished product. Along the way, machines cleaned it, sliced it, fried it, seasoned it, inspected it, and protected every crunchy bite. What looks simple on a supermarket shelf actually represents farming, food science, engineering, automation, logistics, and countless quality decisions. And every stage exists for one simple goal: delivering the same satisfying crunch from the first chip to the last. But perhaps the most remarkable part is how thousands of tiny decisions disappear into something we casually call a snack. Soil composition and potato selection to fryer temperature and packaging atmosphere. Precision controls the entire journey. Even the famous crunch depends on controlling moisture, heat, thickness, cooking time, and final packaging conditions. Miss one variable, and the texture, color, flavor, or shelf life can change dramatically. That's why modern chip factories operate like enormous synchronized systems, where thousands of movements happen almost simultaneously. Yet despite all that automation, skilled workers still monitor the process, solve problems, and make critical decisions. Their experience helps keep technology, raw ingredients, and human judgment working together without missing the smallest detail. And when the final package passes inspection, another invisible system takes over: distribution. Trucks, warehouses, scanners, retailers, and delivery networks carry the finished chips across cities and countries. Eventually, after traveling through that massive network, one small bag arrives quietly on a shelf. And that's the moment the entire industrial journey becomes invisible, replaced by one simple choice: which flavor should you grab? But now you know that behind that simple choice sits an extraordinary chain of people, machines, science, and precision. The humble potato has traveled from earth to factory, from factory to package, and finally into your hands. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.